let's give this a go. So I've logged into the server now, and this is where the room starts getting quite hot because I'm sat in a room, lots of computers, and they're all whirring away. So I've gone to create a new project. So I'm just going to do slugs 2. I've also got a backup project just in case things go wonky. So I'm calling this slugs 2. And I'm just going to do a quick detection task. I'm going to detect a slug. We go to create. And then we upload our images. And then we have a swig. So what I want to do with this project is just detect slugs. It's a very simple problem, but it just illustrates the way the system works in quite a quick way. So here I'm using the Surface Pen, and I've got the box tool. So now I can just start drawing boxes around slugs. And you can see in the bottom left here, it tells you how many annotations are needed to start training the system. So I can just quickly go through, very, very quickly building a data set. One more. Bang, done. So that's going to go off, that's going to start training the first round. But we can carry on. We don't have to wait for that to train the first network. We can carry on training, we can carry on building a data set. And I've spoken to a few people that have done this on a few other projects, and I say it's actually quite therapeutic. They sit down in front of the telly with it and just sit there drawing bounding boxes on their problem all day. And quite a nice way to switch off, apparently. So it's as simple as that. So already within no time at all, we've got a data set built, we've got 15 annotations. So after a minute, it's going to do the first round of training, and then it's going to come back, collect all those new annotations that are provided, and then it's going to go off and do a second round. So while we wait, is there any other questions?
So I'd say that's okay for a sparse data set, but if you've got a lot of things in the image, could that not take a long time? So for example, with those images, if you were selecting grass,
yeah,
you were trying to identify grass, I guess possibly you'd use something other than a bounding box.
Yeah, so we've got some assistance built into it, which I can show you in a sec. I'll do that as a second little mini demo after this. So there you go. So that's the first round trained, and I'm just going to go through and generate some results. Now it's picking up the next lot of images, and it's going to go off and train again. But we can start looking at some of the results from the first round, and as I said, it's probably not going to produce anything because we've only given it 5 images. So when it comes up with the second round of training, we should get some results coming through now. It's not the fastest GPU in the world, so it does take a couple of minutes. The learners that we use the big Titan RTX cards. This is an old 1080, so it's a little bit slower. So there we go, onto the next image, and it started producing some results already. Now, what we use something called active learning. So when you go, you can browse the images normally and try and select an image that you want. But the key thing with the system is the active learning. So when you click next image in the bottom right, the system will pick the one that it's most uncertain about. So in this case, you can see it's actually, there's 2 slugs in the image. So there's an internal score that the system comes up with to say that actually this image is most uncertain for me. Can you correct me on this image? And then I should be able to learn a bit quicker. So I can say, yeah, well, you missed one, missed that one there. And then I can go to the next image, or I can say, actually, that one, you could improve that a little bit. So I'll make that a bit smaller. So we go to the next, and then say, right, you missed that one. Go on to the next, not bad. I think you could do a little bit better. And so on, you can just carry on. Now, I'll just go back to one of the other projects. So you basically carry on doing that and then you end up with this. So this is my Blue Peter moment, where one I created earlier. And this has only got 75 annotations, so it's not hundreds, it's not thousands of images. It didn't take ages to build. It only took about 10 minutes. And here you can see that we've got 82% accuracy. So if I go and select just a random image, there we go. Got some nice slugs detected. And I think. So it's as quick as that to train a slug detector. Now, if you're asking about if you're trying to detect difficult things, so I've got a test set here. This is one of our customers. They came to us and said, we're trying to detect the holes in a honeycomb. And I thought, blimey, that's a lot of annotation to do. Don't fancy doing that. So we've included a bunch of smart annotation tools. So this is a detection assistant. So you can just pinch to zoom in, a nice and friendly interface. And then you can just draw a box around something and go, yeah, I want to detect that. And the detection assistant will quickly look at all the rest of the image and go, these look quite similar to what you're trying to detect. So I think this answers your question, Mark. But, how do you annotate lots of things? There's smart tools integrated into that.
Yeah, no, that's great.
And then you can just tune how many you want. You'll probably get a few false detections coming through, so then you can just wind it down a bit, and then you can hit save. And then you say, well, actually, I want a few more, so you can carry on and go, actually, I want all these ones as well. Now, quickly go off, and then it'll add those to the data set as well. And then you can turn that off because it gets a bit busy. There we go. So yeah, there's a whole bunch of tools that are integrated to try and speed up that annotation process, because when you're building some of these data sets, your expert's time can be really expensive. If you're building a cancer data set of particular cells, if you're doing some histology analysis, the clinician's time can be seriously expensive. So you want them to try and be able to build their data set as fast as possible, really. Cool. So that worked, which is always good when a demo works. Now I'll flip back to presentation. No, wrong one. Now this is a little side thing that I've been having to play around with. Hopefully most of you are familiar with what augmented reality is. So this is where you're super lazy and you don't even want to draw bounding boxes. So we use AR Core and Core, what's the other one? ARKit. So this is now running on Android phone, which allows you to scan the scene. So this is where the AR Core uses the IMU in the phone and the visual tracking of the camera to build up a 3D model of the scene. And here you can then draw a 3D bounding box around the object that you're trying to track. And then because the augmented reality can keep track of where an object is in 3D space and where the camera is in 3D space, we can then project that back into the camera coordinate system. And then we can just basically create a bounding box for free. So then all you have to do is just move around the object, click save, and then yeah, you can build your data set with pretty much no effort whatsoever. Is everything working? So I see some lost audio.
I think it's only affecting Paul.
Yeah, it's fine.
Okay, cool.
Yeah, I can still hear you as well.
Yeah, it was just me. Sorry.
Where was I? Oh yeah, so yeah, this builds your data set really quickly, and then you'll see in a second when I log back into the Noose platform, it'll have a full populated data set with not a single bounding box drawn, just one 3D bounding box. And there we go, data set created super quick. Cool. So that's the first half. That's a bit about the company and Cosmonio and our Noose platform for training AI with not a single line of code written. Are there any questions?
I've taken a few screenshots of you drinking a beer and presenting. Can I share them?
Does NUS use
I guess so.
transfer learning? And we've got a question on the chat.
Ah, yeah. Yes, yeah. Well, we can use pretty much anything basically. By default, we use pre-trained networks, but we can also train from scratch. So it's a completely platform agnostic as well. Sorry, framework agnostic. We can use TensorFlow, PyTorch, the Microsoft one, CNTK.
CNTK.
About it.
I got a question.
Yes, Rodolfo.
So, yes, you use Amazon Web Services as a platform also, cloud platform.
It can be deployed anywhere. So we use Google Cloud. We could use Azure because it's all built on Docker.
Okay.
So anywhere we can run Docker, then it's fine.
So it's not only based on local GPUs as you did now, but you can run on GPUs in the cloud.
Yeah, that's correct.
That's great.
But the cloud GPUs can get pretty expensive pretty quickly. Cool. All right,
I've got a question. Does it always have to be kind of images that you're recognizing, or could you look at other data sets? Like if I work in like the control industry, so often, we'll have scenarios where, we've got a lot of data and we don't always know how to work out what's happening and tying events to data. Could it kind of look at, data sets that are just, say, sensor values as well?
So at the moment, it's primarily image data, but we have processed other images through it using, so you convert the data into spectrograms, so you could process audio through it that way. We haven't done much work with, sorry if I'm hearing dogs barking outside. We haven't done much work with raw data streams yet, but in theory, there's no reason why it couldn't, because we'd just be able to make a module that could import that sort of data into it, and then we'd have to look at how you might interact with it on the front end. But there's a full SDK and API for the platform as well, so it shouldn't be too difficult to make an interface that could process data streams rather than images.
Okay, cool.
Do you do also segmentation?
Yeah, so we do classification, segmentation, counting, detection, anomaly detection, all sorts. Basically, any of the latest algorithms we can put into it. So we built the framework so that it can accept any type of task. There's also something that I suppose I can quickly go back, which is probably one of the coolest features. Give me 2 seconds. This probably won't work on my machine because my GPU isn't the strongest. So we go back to demo host. When you create a new project, these are all the tasks that we support. But we've also got something called task chaining. So here you can then actually customize the pipeline fully. So here you've got your image data set, and then you can say, right, I want to detect an object first. Then you can add a particular label of something. So say, let's go for the slug example again. So you've got your slides coming through, and then you can add a crop task, and then you go through to your classification task. So then you might want to decide you need a classifier to tell you what type of slug it is. So this allows you to build completely custom pipelines to do any task.
How do you sell this? You sell the platform, you sell the service?
Yeah, we sell the platform.
Okay. Thank you.
Cool. Okay, I'll go on to the IoT bit now. So hopefully this will be for the IoT folk, be a bit interesting for them. So this is just a personal project on how I've used AI and IoT together, and this is what I'm hopefully going to be using the Vizi AI for as well soon. Shut the window. Cool. So there's a bit of a problem in most parts of the UK. I think everyone's experienced this at some point. That there's quite a lot of people using off-road bikes, particularly in rural areas, and it can be a bit of a nuisance. It's difficult to police. All the bikes often have no number plates on them. It's difficult for members of the public to report because by the time they've got the camera out, they've either gone or people are afraid to get the cameras out because they might be attacked or something. And it's even more difficult for the police to catch. There's no way they're going to chase them down there in a car or on foot. One of my neighbours called up about them not too long ago to the police, and they sent a bobby on a bicycle, which I don't know what he was meant to do to try and stop these guys or catch them. And the fact they often use cycle paths and road and cycle walkways to get to these off-road areas. It's just it's an accident waiting to happen, basically. Now you can put CCTV everywhere. That costs a fortune. It needs a ton of bandwidth to stream live images back continuously, and you need someone to be sat there watching it. And in this room here, I think it's about 155 screens with like 5 people watching. That's a hell of a lot to be keeping track of continuously. And then if you need to search back through the data, back through the images to find something, that's even more effort. So it's really not ideal for understanding from the text. So of course, how do we solve this? Get rid of this quickly. Sorry. We get a machine to do it. So the advantage are the machine knows exactly what it's looking for. You've tasked it to do a particular thing. So it doesn't have to, like a person, it has to look at those screens and think, right, is that person trying to rob that person? Is that car doing something wrong? Is this person doing that? They're having to monitor everything. Whereas a machine can just be tasked to do 1 or 2 things and do it really well. It only has to record certain things. You don't have to record everything. You don't need a ton of storage. You just need to say, right, these are the things I'm interested in. These are the things I want it to record. And then of course, if it's a machine, it can interact instantly with other devices. So it can send a text to someone, it can tweet something, it could do all sorts of things. You can have instant interaction, which is the IoT side of things. And of course, it's the 24/7 monitoring for to make sure performance doesn't drop. So I thought, brilliant. I can solve this. Got the camera. I've got a location where it can be pointed. Let's have a go at trying to make some sort of smart CCTV. So version 1 was just taking a camera and just sort of finding out what other hardware I've got lying around. I've got a mini ITX running Ubuntu, and it's not the best. It's about 10 years old, running an old Atom chip, so it doesn't really have much processing grunt. I've also got home server. That's got just a small 1050 GTX in it, which is a fairly modest graphics card, but it's enough to do some inference on. I wouldn't try and train any machine learning models on it. It's only got 2 gigs of RAM, but it's enough to do a bit of inference on it. And then we can have the server decide whether it sees a bike, and then we can write that to disk. So I thought that's pretty easy. Let's give that a go. Turns out it was easy, and it worked super quick, super well. First off, so straight away we detected a guy on a bike and his friend following on behind him. And I think yeah, results aren't too bad. We can easily recognize when people are on bikes coming past, but you know, the actual recognition of the person might be a bit more difficult. So yeah, we can definitely do better. So it's time to look at adding some big guns into this. That's the big guns. So we get an old SLR. This is again, it's about 10 years old. It's Nikon D90. So it's not the latest greatest, but it will do the job. Then we've mounted the camera on top as well, just to make it look extra cool. So now the setup is we've got the ITX server, which is pulling in the images from the camera. That sends it off to our home server still. That's still making a decision using a pre-trained network as to whether there's a bike in the image. Then we save that to disk. But now we're talking to the Raspberry Pi as well. So I'm quite into the home automation stuff. I've got Raspberry Pi running MQTT and Node-RED, things like that. So I've got the MQTT broker. Hopefully most people know what that is. If you don't, it's like a little message board where devices can post messages to this board, and then other devices can read messages from them that broadcast from a particular topic. So here the home server broadcasts a message on the, I can't quite point to it, on the topic of camera/D90. Then we use a little device called an ESP8266. I'll come on to what that is in a second, but it's like a little Arduino, and that subscribes to the topic camera D90. So it just sits there watching for any messages on this channel. And because it's an Arduino, we can do some cool electronics with it, really basic, but we can then trigger our SLR. This is what the little ESP8266 looks like. These are wicked little devices. I fully recommend having a play with one if you haven't. They're only about £5 off eBay. You can get handfuls of them, and you treat them just like an Arduino basically, but they've got Wi-Fi on board, bunch of GPIOs, and a one analog to digital converter. The new version, the ESP32, has got Bluetooth Low Energy as well, so you can do some really cool stuff with that. So this connects up to our DSLR, and you'll see here when it triggers, the blue light will flash on the ESP, and then the little green light on the SLR will flash to show that it's taken a picture and saved it. So right, let's set that up. So that's the image that we had from our V1, and yeah, so it's good enough to recognize when bikes are in the scene. Dynamic range isn't great, and it's only 1.3 megapixel. So what happens when we bring in the big guns? Boom. Much better. Got significantly higher dynamic range. It's it's a photography device. It's designed to have high quality images captured. It's only the Nikon D90, so it's only the 12 megapixel one, but we could easily swap it for one of the new D850s that has 46 megapixel. What we just swap out the connector for the trigger, so you get ridiculously high resolution images. This is actually a crop. I'm in the way. Get this out. That's actually the full frame image. If I had a longer lens as well, we could get even more detail on the person, but that's the only lens that I've got. So if you zoom in, you can see that it's definitely a lot more detail. You can see the Nike logo on the shirt, so that gives us a bit more information to pass on to the police. So that worked pretty well, but we're using a Ubuntu Mini ITX. We've got a home server running. We're using a Raspberry Pi. That's quite a lot of kit, and the girlfriend wasn't too happy with having DSLR hanging out the window. So I thought, all right, let's improve this a bit. Let's get rid of these two for a start. These are quite big machines using a lot of power, not very efficient. So we started to look at using some of the Coral USBs made by Google and the Neural Compute Stick from Intel, and plugging that into the Raspberry Pi and seeing how we can get the inference done on these devices that are specifically made for doing low power inference of machine learning models. There's also the Jetson Nano as well. I didn't have one of those. And Coral dev board, which is pretty much the same as a Coral USB, just all integrated into one unit. So this is my shelf. Ignore all the crap around it. This is a couple of Raspberry Pi 4s in my little cluster, which I'm just playing around with the Neural Compute Stick 2 and the Google Coral. So I haven't got any power readings on the Raspberry Pi 4, but on the Pi 2, the whole system draws just less than 4 watts and runs at 5 frames a second, which is the same speed it was running at sending the images to the 1050 GTX. And on the Pi 4, it runs at about 25 frames a second, but also using more power. My power meter doesn't use USB-C, so I couldn't test that. So in Smart CCTV V3, I've had to play around with the Coral, and I can say it's a really nice bit of kit. It's super cheap, fast, small, low power. But I would say it's typically Google. It's an early beta. API goes through changes all the time that breaks things, which is a bit frustrating. And always in the back of your mind, there's the niggle that the sword of deprecation at Google swings fast and hard. If you go and check out Killed by Google to see how often they chop down products and services, and you think, oh, not again, not another one. And so I think it's still definitely in beta. As I was using it, the device memory just creeps up and up and up. Comment out the Coral inference code, and it's fine. So a little bit frustrating using that. So in the next version, definitely going to ditch the dongle. This is where Paul comes in with his Vizio AI to the rescue. I'll be having to play around with this next and looking at how I can get the models running on this and get it all running on a single board. No faffing around with dongles. Then that actually frees up another USB port for another camera if I potentially wanted. So quick plug for Go250. Again, this is the community that Paul set up. I'll hopefully get some more updates on this project at some point, and I'll be posting on there. So if you're interested, you can follow along there. Cool. So that's pretty much it for me. Thanks for humoring me, and hope you've enjoyed it.
Yeah, it's really good.
Awesome. Brilliant. Thanks, Oliver.
Nice one.
Right.
Ooh, we got a thanks. We got a thanks. Oliver, that was absolutely brilliant. Thanks very much. Guys, do you have any other questions for Oliver while we've got him still online? No. Okay, guys, thanks very much. I believe, Rodolfo, did you commit to next month?
Hey, yeah, that's going to be me.
Yeah. Okay, excellent. So we've got Rodolfo next month from Pervasive, which will actually see the reactions from sort of the object detection to actually start to create reactions to it. Oliver, I'll give you an introduction via email to Rodolfo as well. I think it'd be really good for you guys to have a chat.
Fantastic.
That was absolutely brilliant presentation. Really appreciate it. Guys, stay safe, and I'll see you next month.
Cool.
Awesome.
Bye,
Thanks for everything.
Cheers.
Stay safe.
Thank you.
Nice one,
Bye.
Oliver. Cheers.
Thank you.
Thank you.